Hey guys, we're going to look at our next exponent rule and our last one with rational power. So basically what that means is that you're going to take a base, some sort of exponent, or maybe even a number, and raise it to a power that looks like a fraction. We'll look and see what that looks like. We're also going to use the radical sign. So that's like a square root. So not all of them are going to be square root because of that little number out front. We're not going to look at that in too much depth here, because a lot of what you'll see is going to be basically the power rule, taking, multiplying there, but just so that you're kind of exposed and see how that looks as far as, a fraction as an exponent, and that can work. So our rule that's going to be on the formula chart is a raised to the m divided by n power. So it's like a fraction is going to be equal to the nth root. So that's where that little n comes from out here in front. So the nth root of a to the n power. So basically the denominator goes out in front and the numerator goes with the variable underneath the radical sign. So you can see our example here. If we have a to the 3/4 power, it's going to be equal to the fourth root of a to the third power. So the 3, it goes from the top to inside, and then the bottom to out front. So you'll be able to see this like this section here will be on your formula chart. So you have to remember, well, which one does it go? Just follow where m and n separately go. So our first example, we're going to go ahead and use it with the radical sign. The rest of these are not going to be written with the radical sign. It's basically just the power of the power rule. So we have x to the 3/5 power. So remember that the denominator goes out front. So I'm going to have the fifth root of x to the third power. And then that's just it. So you stay there. If you had like a number out in front, you could raise it to the third power, go ahead and multiply that out, and then take the fifth root of it. But I don't think you're going to see very much of that. And that's just as simplified as it gets. So let's say that we have x to the 10th, y to the 16th. All of that is raised to the 1/2 power like we have in example 2. So to simplify this, remember I'm going to take a power to a power. So when I take a power to a power, remember I'm going to multiply those two exponents together. So here we have x to the 10th times 1/2. And then y to the 16th times 1/2. So remember that it goes to both of those numbers. I'm going to multiply both 10 and 16 by 1/2. And I would get x to the 5th divided by y to the 8th. And then that's simplified there. All right, so you'll see here that I have a little bit more involved problem here. So I'm going to take x to the 3rd, y to the 12th to the 2/3 power. And then I have a division problem that I'm going to take to the 1/3 power. So what I'm going to do first, I think I'm going to go ahead and simplify inside this parentheses here by dividing. Remember, when I divide, that means I'm going to subtract exponents. So that's going to be x to the 9th, y to the 6th. So I took 12 minus 3 gave me 9. And then 8 minus 2 gave me 6 here. And that's raised to the 1/3 power. And then I still have x to the 3rd, y to the 12th, all raised to the 2/3 power. So here I'm going to take x to the 3rd to the 2/3 power. So that's going to be a multiplication there. So I'm going to have x to the 3rd times 2/3 times y to the 12 times 2/3. And then that's going to be multiplied. So that's this part right here. Okay. And then the other part that we have going on is going to be, and I'll write that one in red, x to the 9th times 1/3. So that 1/3 applies to the 9 and the 6. And then y to the 6 times 1/3. So now simplifying down one more time, I'm going to go ahead and multiply those out. So I would have x squared, y to the 8th. So that's 12 times 2/3. You can plug that into your calculator. and then times. So this part here is going to be x to the third power and y to the second power. And so I'm multiplying here. So I applied the rule, basically power of power rule, but with rational powers as well. And then I did division, and then I did power of a power. Now I'm doing multiplication. So you can see how this layers together. And this is exactly how it's going to be on your test because they want to get as many rules as they can in one problem. So remember, when I multiply, I'm going to add exponents. So I would have x to the 5th because that's 2 plus 3, and then y to the 10th because that is 8 plus 2. And that is your simplified form. So that's a way more involved problem there because we had so many layers of those exponent rules. So I would say most of the time you're going to see this rule basically coupled or layered with other exponent rules. But if you don't, if it's just by itself, remember that the number outside of the radical signs is going to be the denominator. And then likewise, is going to be that denominator of the exponent. So if you have a fraction, that doesn't mean that you're going to start using like a fraction coefficient. That does not mean that you're going to start using that radical sign there. And then the number inside the radical sign is going to be the numerator of that exponent. So remember, this is kind of a big thing. So that's of the exponent. It's not just of your coefficient. Okay, your coefficients still follow the coefficient rules. And so this is it, all of our powers together. On our next lesson, we're going to look at these kind of all jammed packed together, and we'll see what we got.